Good evening, everybody, and a very warm welcome to all of you. I am Yashraj Singh, and I'm delighted to welcome all of you on day two of Women and Girls in Astronomy 2026, organized under International Astronomical Union Office of Astronomy Outreach. This global lecture series celebrates women who are leading charge in astronomy, space science, and aerospace. Today's session is titled Bring Back the Dark Skies, Citizen Science, and Career Opportunity. Well, dark skies are not only important for astronomy, but also for sustainability, science awareness, and equal access to the universe. Today, we'll learn how citizen science initiatives are helping protect our night skies and how these efforts connect to real science opportunities. This session is organized by Propagation Institute for Advanced Studies, a dedicated school focused on space science and technology. We work with students from school levels onwards and aim to build one of the world's largest scientific communities. And we are proud to collaborate with SA Citizen Science Group, India's largest civil science community. I would also like to share that registrations are now open for Summer School of Astronomy and Astrophysics 2026 and Summer School of Rocket Science 2026. These programs are designed to give students strong fundamentals and real exposure to space science. Please remember that certificates for this series will be issued after 8th of March after all of the lecture series is concluded. Now, it is my honor to introduce our speakers, Dr. Mila Mitra, who is a former scientist at NASA, who has done a PhD in astronomy from Rice University, worked at Goddard, Ames, and SLAC, mentor for International Asteroid Search Campaign, STEM education leader. Well, Dr. Mila Mitra will begin today's session and guide us through the importance of dark sky preservation and citizen science initiative. And we have another great speaker today, Wanjiku Kanjumba, who is a CEO and co-founder of Vicillion, Aerospace Engineering and Astronaut Candidate, who is a PhD student in Aerospace Engineering. And after Dr. Mila Mitra's session, Wanjiku Kambuja ma'am will take over and guide you on with global career opportunities in space science and aerospace engineering. We are truly honored to have both of them with us today. With this, let us begin. Please join me in warmly welcoming Dr. Mila Mitra. Thank you, ma'am. Please go ahead.
Hello, welcome everyone. Thank you again to Propagation Institute and SA Citizen Science Group for inviting me to this talk. And I understand that the previous talk went very well. So let's get some energy going so we have fun in this one as well. So today I'm going to talk about, as he mentioned, I'm going to be talking about dark sky awareness. And he made a very good point, because usually we think that dark skies and light pollution is something that only astronomers and astrophotographers need to worry about. But in fact, there are a lot of people who do need to worry about it. So I'm going to go ahead and get started, and I'll interact with you in between. So I'm first going to, with a presentation, guide you through what is light pollution and what are we going to study. And then I'm going to lead you to the citizen science web page called Globe at Night, and I'll show you more. On that web page, I will show you how to do it. Okay, so what is light pollution? So from the picture, and I'm sure all of you know, light pollution is excessive, unwanted artificial light. So, artificial light is human-made, and some of it is necessary, but some of it is beyond what is necessary. Also, it's not planned properly, in which case, light pollution leads to a lot of issues. So here is a picture before and after of the same location. The after is when there was a blackout, so the lights went out, and you can see the Milky Way on the right-hand side. Here are some light pollution interactive maps, and I've also given the URL. So if anybody wants to go and play with this, you can. In this website, you can also go and click on your location, like I'm sitting in Delhi, and you can see what the light pollution level is in that location. So this really helps people who are planning a photography session. Okay, so look at, I'm starting with 2012, and we go to 2018, and we go to 2023, and you see there's so much more lighting all over the continents. Okay, so with that, there are light pollution is broadly defined in these categories. I'll start with the second one first, which is sky glow. All of you who are in cities or urban areas, look up, and it's no longer a dark sky, right? It's just this ambient light or an ambient glow. And how is this glow created? It's all the lights that are facing upwards that are going into the atmosphere and reflecting back from particles and water droplets. So there is kind of a halo or a glow around us. Now, the first one is glare. And I'm sure some of you know, I don't know the age category here, but if any of you drive, you know that when you're driving and sometimes people flash their lights or they have their high beams on, and that's a glare because, glare comes across as a very strong light. And not only is it a strong light, sometimes it even reflects back from other surfaces. So glare can actually be very harmful. It can be harmful for the eyes. It can cause traffic accidents. And, it's unwanted, sudden, strong lights. Light trespass, the third icon I have. Light trespass is when you have a light meant for a specific purpose, but you haven't planned it so that it shines in whichever area you want it to shine. Instead, it goes across, maybe to your neighbor's house, maybe to neighboring areas, and that's called light trespass because you're bothering and disturbing people for no reason, because that's not where you wanted the light to go. Okay, overlighting. And we all know this, right? There are shops, there are malls, there are restaurants which have such strong lights, and it looks attractive, but is it needed? And is it needed after hours? So this is called overlighting, and again, that can lead to a lot of light pollution. So just to describe more of what I was saying, you can see this is a diagram that shows that on the left-hand side, there is a useful light cone area, which is where the light should be going, but then it also goes, because this light is not properly filtered or it doesn't have proper shielding, so it goes up into the sky. That's the direct upward light and is reflected back due to the clouds. It also goes into a light trespass and goes into the next house. So these kind of things can happen. So what are the effects? Again, most of us here are worried about the effects on our dark skies and what we can see. And eventually I will talk about that. And that is, of course, a very important thing. But there are other issues. Energy, safety, and cost. It's the same thing as any other overusage of resources, especially electricity resources, because if we are keeping the lights on when we don't need it, or if there's overusage, then there's energy and the cost and the carbon dioxide used to create this electricity. All of these are adding to the carbon footprint. Now, Earth and the ecosystem and the wildlife, I'll talk about both of these. Many animals are nocturnal, which means they have a day and night cycle. So when there's too much lighting, then animals get confused. So like sea turtles forget how to go back to their nesting areas. Migrating birds forget their migration patterns. And so the whole ecosystem might change. There might be animals that move away from the cities, animals or birds or insects that move away from the cities because they want the dark areas. So whole ecosystems can change. Now, human health and vision. Humans have a cycle that is based on 24 hours. It's called the circadian rhythms. So it's a 24-hour day and night cycle. And if you don't get that cycle, if you have overlighting, it can disrupt your sleep patterns. It can cause health issues. It can cause eyesight issues. So all of this can happen. And not having a day and night cycle for humans can even lead to other medical problems like immunity loss and so on. So we have to worry about all these issues. Of course, air pollution. With air pollution, the extra light reflects back more and there's more of a glow. Astronomical research, that is what we're going to talk about. Now we also have these satellite constellations. What does that satellite constellations mean? Large numbers of satellites, like Elon Musk is sending large number of satellites. There's like a train of satellites, and they cause like a lot of satellite tracks, and they really affect observatory and astronomers, what they can see in the sky. So the causes of light pollution is irresponsible use, excessive use, cars and vehicles, signposts and streetlights, malls and buildings, night lights that are undirected. Undirected means they're not focused in the right area, smog and atmospheric glow, and new problem again is satellite constellations. And so nowadays, as you know, in the last few years, we have large numbers of small satellites that are going. And of course, we want them because we want more broadband options and connectivity options. But these have led to a lot of problems. They are a threat to astronomy because they are at the low Earth orbit, LEO. So they create artificial star trails. They create visibility problems. And they disturb a lot of astronomical research. So what can we do? There are ways to solve it or to make it better. So that will involve planning and educating people. So what do we do? Light what you need, when you need it, and no brighter than needed. So this includes things like you can have LEDs, lower temperature LEDs, warmer lights, motion sensors that put on lights only when it senses somebody. So if there's a problem of safety, that would be an important thing. Directing outdoor lights with shields, turn off lights in empty buildings. So this is an example. The first one, the light goes everywhere. Then the second one is a little better because it's got a shielding on top, and then it gets better. Basically, you need to point the light downwards into the specific area. So with that, I'm going to now lead it to how it affects astronomy and how we see the stars. And I'm sure many of you here are aware that light pollution affects how we see the stars, but I'm going to make a connection between the two. Okay, so again, night sky and light pollution. Did you have a question, somebody? Okay.
No, I didn't think so, ma'am. No.
Okay. Okay. So, okay. So this is a picture of the, on the right-hand side, we have an excellent dark sky site. And you can see, when you have an excellent site, you can see the Milky Way. And gradually, as you go to rural, suburban, inner city, you don't see anything at all, right? So this, astronomers call it the Bortle Scale. I'm sure you've all heard of Bortle Scale. And Bortle Scale, it's a funny word. I've seen people call it bottle, B-O-T-T-L-E, a lot of things, but actually the spelling is B-O-R-T-L-E. What does it do? It gives us a way of quantifying the local night sky based on the observability. So the observability is, of course, how much you can see based on your light pollution. Okay, so Bortle Sky 1 is the best. It's the rural skies, not even rural, it's the dark sky areas where you can see completely all the features of the Milky Way. And as you go to Bortle Scale 9, you're in the big cities where the number of stars you see are very less. So with that, this gives us an understanding that therefore we can use this concept, which is light pollution can be measured by what are the number of stars we see. with our naked eyes. This term is called naked eye limiting magnitude, or NELM. So again, you can quantify light pollution. All of us sitting here right now, I heard him ask, which cities are you from? I'm from Delhi, somebody's from Orissa, somebody's from Bihar. All of us can see different number of stars in our night sky. So light pollution can be correlated and determined by the faintest stars you can see at your location. Okay, it's the faintest, not the brightest. So this helps us quantify, and that word is called limiting magnitude. I'll explain a little bit more what is limiting magnitude, but first let me just show you. This is Orion, and most of us can recognize Orion, by the 3 stars of its belt, and Betelgeuse at the top left, which is the arm of the hunter, and Rigel, which is the bright star, at its leg. Okay, now here's Orion under different skies. This is Bortle level 9, which is the inner city skies. You can only see the belt and Betelgeuse and Rigel. Then as you go higher, as you get better and better, which is lower light pollution. So this is Bortle level 5, medium light pollution. You can start seeing more stars. And in rural skies, and this is Bortle level 1, you can see a lot more stars. So again, that is the definition. Let me explain to you what is magnitude. And again, I have a very mixed audience, I'm sure. So maybe some of you already know some of these things, in which case, maybe you can just revise what I'm saying. But for some of you, it might be new. Now, just the way we have light bulbs and we say this is 100 watts light bulb, or 200 watts, that defines the brightness. The same way, a star is defined as, the brightness of a star is defined by the word magnitude. Now, magnitude is confusing, it's tricky, because magnitude also depends on how hot the star is, how big is it, how far away it is. So eventually we get rid of all those problems, and we just say we are going to take a term called apparent magnitude, which means how bright does it appear to us on Earth, regardless of the distance and all that. So it's a relative scale where 0 is the middle number, and 0 is what the star Vega actually is assigned to. Now, so apparent magnitude is how bright a star appears to us. So, therefore, looking at them, you can say this one is brighter than the other one. We're not worrying about how far away it is or how big it is and all that. Okay, so it's a relative scale. So this is the apparent magnitude, where the lower numbers or the negative numbers are greater. So this is kind of a reverse scale, inverse scale. Lower, as you go lower and lower into the negative numbers, it's a brighter number. So the sun is at about -26. And all the way to the right, you have Hubble Space Telescope at +26. Now the naked eye limit, the limit you can see with your eyes, is only 6 or 7, not beyond that. So beyond that, to the right-hand side, you need telescopes. Okay, so I'm going to ask a question. Okay, so again, sun is at -26. The full moon is at about -13. Naked eye limit is 6. Okay, so I'm just going to ask you a question, and let's see in the chat if any of you can answer. What do you think is the apparent magnitude of the crescent moon? Anybody can answer that? Let's see. And I'm not sure I can see the chat right now. Okay, so what is the apparent magnitude of the crescent moon and of Venus? Okay, so as I get the chat, I'll give you the answer. Okay, crescent moon is about -6 to -10, and Venus is -3 to -5. Remember that Venus is the brightest, one of the brightest objects you see in the night sky. Pole star is positive, it's +2. Okay, so again, these are the apparent magnitudes. And just to explain a little further, you don't have to remember this. Each magnitude is greater or less than the previous magnitude by times 2.5. So it's a reverse logarithm scale, which is every time it's times 2.5. So if it's 0 and 2, then it would be times 2.5 times 2.5. Okay, so a difference of 5 magnitudes is almost a difference of 100 times. So the brighter the object, the lower the number. So let's remember that, because that gets kind of tricky. Okay. So now how do you connect light pollution to limiting magnitude? So when you go out, you'll see this citizen science project is going to guide us to one specific constellation. In that constellation, you'll have to see what is the faintest star you can see. Okay, so less light pollution, you'll see more faint stars, or reverse. Okay, so what is the faintest stars you can see? Based on that, that is the limiting magnitude. Limiting magnitude is the minimum bright star, or the faintest star you can see. And remember, faintest star means it's a higher number in magnitude. So if it was magnitude 4, that's what you would see. Okay, so remember, this is all a opposite scale because magnitude goes reverse. Now I'm going to go ahead and go into this website, but let me first describe it to you. Globe at Night uses this concept, and Globe at Night has been going on for many years, at least from 2006. And it's an international citizen science campaign to raise public awareness about the impact of light pollution. So in this, citizen scientists are invited to look at specific constellations. Every month, the constellation changes, but everyone around the world observes the same constellation, finds the number of stars and finds the faintest star, and you submit your report. So that helps build up a light pollution map throughout the world. Okay, so this is, again, what are we going to be doing? Observing constellations. That gets connected to our local night sky brightness. So here are the easy steps. Observe the same constellation all over the world. Everybody in the US, Africa, everybody, maybe not the Southern Hemisphere. They're sometimes they're given a different option. So in the Northern Hemisphere, everybody observe the same constellation. You count how many stars you can see, and they give you a magnitude chart. You match it, then you report it. Okay, so you report it along with your location and other factors like the clouds. So what you do again, you find the faintest stars, which will define the level of light pollution in your location. So in February 2026, the recommended constellations are Orion and Perseus. Now, Orion is very easy to find, and every month the constellation may change depending on how well it can be seen and how high up it is. So these are the easy star hunting steps. We will all go to this app. I mean, when I mean an app, this is what you can type in on your phone or your laptop, and it will lead you to it. So everyone has to go outside at night, find the constellation, go to the Globe at Night reporting app, enter the date, time, and location. And of course, mostly it will automatically do it for you. You match a star chart and you report it. Okay, so that's how this works. And they give you these magnitude charts that you can use to find what are you looking at. So for example, this is the Orion magnitude chart. You can look at your phone and you can look up at the sky and you can see, is it magnitude 1, which, as you can see, doesn't even show the Orion belts. That means it's highly polluted. Then if you come to magnitude 3, magnitude 2 is about 2 or 3 is about what I can see from Delhi usually. Again, you can match it you see the three belt stars, and you see the bright stars above and below. Okay, so just to help you find Orion, everybody can find it, and nowadays we all have software apps that help us. But Orion is easy to find. You find the three belt stars. You find a reddish star on top, and Rigel, which is at the bottom. Okay, so just to help you understand this, these are the magnitudes in numbers. So when in the magnitude chart, when it says 0 or 1, first you'll only see Betelgeuse and Rigel. Then you'll start seeing Bellatrix, Alnilam, which is one of the best belt stars, and then you start seeing more stars. So this is how magnitude 0, magnitude 1, and of course, every time you see faint stars, you still see the bright stars as well. Okay, so this is how the magnitude charts that we have to match it to works. And this is how you'll report on the app. Again, I'm going to show you the website, but the phone is good because you can take it outside and match it. And the phone has an option of going to a nighttime. You can click on top where there's a light bulb, and that makes it a nighttime observation and darkens the fonts. Okay, so we'll go to the website now, which is, if you want, you can go along with me to this website, which is called www.globeatnight.org/web app. Okay, so I'm going to just stop sharing this, and I'm going to start sharing the website instead. Okay. Okay, so this is the Globe at Night website, globeatnight.org, and you can all go to that link, globeatnight.org, and you don't have to log in this case, because they're just collecting data from everyone. They're not necessarily taking the names. Okay, so again, just to show you the links, we are on the home page, and I'm going to go to the About page. It gives you some information about when it started, and it says that so far 200,000 measurements have been contributed from people in 180 countries over the last 14 years. Okay, so now this is the under observe, you can find campaigns, which tells you, so in case it tells you the 6 steps I told you, but do remember, when you go outside to adjust your eyes, it takes 10 minutes for your eyes to adjust to the dark. Okay, so you can go to the reporting and you can report. I'll just show you that. Again, like I said, Orion in February. And if you do this in March, it's again Orion, but Orion and Leo. And then in April, it becomes Leo. So again, they pick constellations that are pretty high up. And you should, they also give you a time period when the moon may not be up. So it's February 9th to 18th. So you can do it tomorrow or tonight. And okay, so this is the one where you'll report. Even the same thing you can do on your phone. You click on the report, and this is how it will show on your phone. And you can say, when did you make your observations, observation date? And as you go down, you see, where did you make your observation? And of course, nowadays, phones and laptops have the GPS, so it will fill it in for you. In case it doesn't, then you have to fill it in. So now in this location comments, you should write something like urban or city skies. Okay, so, or was it rural? So you have to write things like this. So as I go up again, so as I go up, sorry, okay, so these are the magnitude charts on top. Like I said, these are the magnitude charts. Magnitude 2, magnitude 3. Sorry, I clicked on something and it changed. Yeah. And then it says, what were the sky conditions like that night? So you have to say, was it clear? Was it cloudy for half the sky? And so on. And you can even add a little bit more here saying, was it hazy? And or was it like, you can say, there's a street light close to where I measured. And if you have a Sci Starter account, I think a lot of people here have a NASA Sci Starter account, then you can use that email ID. You can list that email ID. Okay, so this is how, yeah, one more thing I'll show you is on that Globe at Night website, there is also, all this data is being used to create interactive large maps. So if you look under maps and data, then you can see data, you can see interactive maps, and the data is also available even in CSV. So for example, if we have someone here who's a biologist and wants to compare this to this kind of light pollution data to the behavior of sea turtles or migratory birds, then they can take this data and try to correlate it. So you can download the data, you can even search for your location and find out what the results are. So every year, and this is by year, so you can change the year and you can see how it was like in that year. Okay, so this is the concept of this Globe at Night. It asks everybody around the world to observe the same constellation. Right now it's Orion because it's pretty high up at about 70 degrees. They'd ask you to observe between 8 p.m. and 9 p.m. So go out, observe, and just report it. Okay, so you can report it just watching your phone on the reporting page. Let's see if I have it up. Yeah, you can just report it on the reporting page. So this is very easy to do. And this helps them build up a global light pollution map. Okay, so with that, I'm just going to, I hope that gave you an idea about light pollution and how light pollution is important, not just only to astronomers. Of course, it's very important to astronomers, but how it's also important to, for health, for wildlife, for, for maintaining sustainability, not using too much electricity. So there are a lot of issues that we have to worry about, and light pollution can contribute to all those issues as well. So this is a great project, and it can help you identify which are the dark skies. So if you're an astrophotographer, you can find where is a good place to go to for photography. And otherwise, you can, play with this, learn how to identify specific constellations, and find the faintest stars, which are the limiting magnitude, and that will directly correlate to what magnitude sky, what is the light pollution. And again, the higher the light pollution, you will see only the bright stars. So your magnitude then will be the lower magnitude, like 1 or 2. Okay, and vice versa. So with that, I hope you all got an idea, and I hope you enjoyed listening about light pollution. So if you have any questions, I'll be happy to take them now.
Yes, ma'am. Thank you so much. We will now move on to the interaction part about today's topic. Before we move on to the totally interaction part, we have another guest. We have Wanjiku ma'am. We would like her to introduce herself, and we will then move on to the interaction part where we both can answer questions from all the people that have a lot of questions, I suppose. So please, Wanjiku ma'am, you can go ahead and please go ahead with your introduction. Tell them about yourself and what you do, and we will move on to the interaction part then onwards.
Okay, so you want me to do my presentation and then we'll go into questions later?
Yeah.
Okay, all right, sounds good. All right, thank you so much, Doctor, for that presentation. That was very informative. There are a lot of things I have lunch today. I never thought I would ever learn today at all. So thank you so much. It was very informative, very practical, great presentation all around. Thank you so much.
Thank you.
So hello,
Yes.
yeah. So hello everyone. Thank you so much for the invitation and having me. So I'm Wanjiku Chebet Kanjumba. I am a Kenyan aerospace engineer, a PhD student in aerospace engineering, and the co-founder of Vicillion, where I'm looking in developing the Omega Spaceport initiative. So, but before any of that, I obviously started off like majority of everyone here as a small child, growing up in Nairobi, Kenya. I was asking myself, you know, the usual questions as a small girl. Why is the moon following me? That was one thing I always used to wonder as a kid. And why does the moon and the sun appear circular? How did I know that the sun appeared a bit circular? Obviously, as a kid, I did stare right at the sun and ask myself that. That type of shape puzzled me as a kid. So those are the questions I can say that really literally started it all for me. So today I want to share how that small girl became an aerospace engineer, building space infrastructure and researching about interplanetary logistics, and then looking into how, you know, who gets to participate in humanity's space future. And it's deeply connected to citizen science movements like Global at Night that put power back in community hands. So starting off, I'll go through like my history. Starting off is, I knew I definitely wanted to do something in science. Initially, I just wanted to be a scientist. That was the objective. And then questioning more about space generated the deeper passion for the complexity and vastness of space. So growing up in Kenya, I lived, as I mentioned, asking why the moon was following me. I grew up as a very curious child. I was always fascinated by the impossible, the unknown, and the unattainable. And outer space really fit that interest for me perfectly. So I figured as a kid, the best way to make space more accessible for myself and others around me was to do aerospace engineering, especially to understand what it takes to explore the cosmos and expanding human exploration. The concept of our existence in the grand scale of the observable universe, where in a perspective, we literally are nothing more than quarks in a proton or a neutron. In the grand scheme of things about the observable universe, yet we define what matters to us in our daily lives and the society that we've created. It puts a lot into perspective. So trying to break barriers and limitations that we currently have and make the impossible possible really inspired me to get into the space industry and then pursue aerospace engineering at that. The other side of the story is continuing with my education in trying to become an aerospace engineer. I ventured out of my home country of Kenya to go to the United States to do my university studies. And the barriers were real because there have been many instances where I've literally been the only woman around in a room, or been the only African at all, or be the only person who is under 30, being surrounded by people in their 40s, 50s, and 60s. But that didn't really stop me into what I wanted to achieve. I looked into building coalitions with people who believed in a vision. And one fundamental aspect is I stopped waiting for permission and just started building the future anyway, without asking really anyone. And thankfully, I was able to surround myself with mentors and peers who saw my worth, and even though this world typically doesn't. The biggest barriers were in terms of access and perception, was like access to resources, training, and networks, and also the perception, being originally from Africa, that Africa cannot lead in space. I have tried to work on overcoming this by staying persistent, building global networks, and proving that through action we can actually belong in this field. So training abroad really exposed me to world-class innovation, but it also highlighted to me the gaps and opportunities back home. And my vision is to take the best of this global knowledge and apply it back within Africa in building an equatorial commercial spaceport in Kenya that will serve the world. So as I mentioned from the very beginning, I'm working on the Omega Spaceport Initiative. We are looking into building the world's first equatorial commercial spaceport. And in context to today's topic of Global at Night, I have faced some key questions about that. So first one being is, how do we launch rockets without causing light pollution, without displacing large amounts of communities, and without repeating colonial patterns of extraction? And my answer to that has been that we look into co-designing peri-urban communities from day one. So we plan to integrate dark sky preservation into the launching site planning. So we also plan on looking into training the local youth as sky guardians who monitor both astronomical conditions and environmental impacts. So we treat citizen scientists as governance partners. Because when a grandmother in Kenya tells me that her grandchild can, no longer see the Southern Cross due to nearby development, that would be a system failure, according to me. And that really does demand a lot of systemic change and a perspective into looking into that. So yeah, but now also into going deeper into this, let me connect this explicitly with today's theme of dark skies, our infrastructure for space sustainability. So for astronomy, as the doctor gave a very comprehensive breakdown on light pollution, really blinds our eyes to cosmic phenomena. It also blinds our cameras, satellite sensors, monitoring Earth's climate, disaster response systems, and space traffic management rely on, that contrast against dark backgrounds. So, watching out the dark sky can also degrade orbital safety. For equity, I would say the communities that are bearing the brunt of this light pollution, which is often low income, often within the global south, are rarely at tables designing light policy or in general spaceport locations. But yet they hold vital knowledge. Elders, tracking seasonal stars for agriculture, fisher folks navigating by constellations, citizen science in Global at Night, restores that agency, which is really amazing. It really says that observation matters and the skies matter. And then looking into my work with the Omega Spaceport, like I mentioned, we are hoping to design a dark sky corridors, so protecting zones from artificial light, to minimize any it minimizes for nocturnal ecosystems and cultural star knowledge. Because space access really without planetary stewardship is really extraction, not really exploration, in my perspective. So for today, if you're a girl or a young woman here for this, especially if you feel you lack the perfect credentials, here's 4 anchor practical guidance I can give. So anchor 1 is start where you are with what you have. You don't really need to start, you don't only need to just start off with a telescope. Great having a telescope, but you don't really have to start there from day one if you're not able to have access to one. You could just need your eyes, a star chart on your phone and the courage to actually look up, document what you see, share it. And that act really shows the observation as a resistance in the foundation of both science and advocacy. Anchor 2, I would say, find your coalition of the willing. Like I mentioned, I don't wait for permission to start stuff or outreach or projects. I would say a great resource definitely is LinkedIn. I've messaged people on LinkedIn, from astronomers to astronauts to politicians to military generals. People on a day-to-day I don't really meet, but LinkedIn is a very great resource for starting up those conversations with people and building, coalition, a mentorship circle and applying for various opportunities that are out there. So your coalition could start off with maybe 2 friends, measuring the sky brightness in your neighborhood. Could start small, but scale with trust into that. Anchor 3, I would say reframe barriers as design constraints. So being a woman, a constraint that taught me to communicate technical concepts across cultures, being from the global south, a constraint that forced me to design low-cost, high-impact solutions. So looking at it, constraints really aren't walls, just changing your perspective on this. They're just the parameters that spark innovation. And then fourth, final one I would say is protect your wonder. The day you really stop lying on the ground to watch satellites or stars pass you by really is the day you're going to lose your compass. So schedule wonder, schedule a time for you to really go back to the fundamentals of what really inspired you into getting into the field that you're in. Join the Citizen Scientist campaign monthly, and let the data serve as your curiosity of propelling you to go even farther beyond what you have right now. So yeah, outside of all of that, I'm also open to you guys, shifting whatever I've just said about the story and the anchors are presented to actually getting to know you guys. So I'm happy to pose 2 prompts. I'm going to post them on the group chat, and please feel free to share in the chat or raise your hand to unmute yourself. But the first prompt will be, what's one memory of the dark sky that shaped you, and what's threatening that darkness today in your community? And then the second one, I would want you to help me to help answer for me. I'm very curious to know from your perspective, if you could design one rule to protect dark skies in your city or your region, what would it be, and what would you need to convince to be convinced on this? So I'm going to post that right now in the group chat. Feel free to answer those 2 questions, those 2 prompts, and yeah, I'm curious to hear from your perspective about this.
I would request Mila Mitra ma'am as well. Ma'am, please put your point. I would really love to see your point as well on this. There are the 2 questions.
I see there are 2 people who have their hands raised.
Sachin, would you like to answer? Sachin or Masoom? Masoom, sir, you can go.
Hello.
Yeah.
Can you all
Hello.
hear me?
Yeah.
Yeah, so good evening, everyone, and thank you, Propagation Institute and Dr. Mila ma'am for such insightful talks. For the question that has been asked, I would like to share that recently I have a pleasure to visit one of the dark sky of our state, which is at the South Gujarat part, and it's a tribal area where people and students were there who were asked to attend an astronaut session, and I'm sharing my insights from the astronomy education that I conducted over there as a part of sky observation. So first of all, it was Bortle Scale 3, So a lot of things which we cannot see from the sky was there, first of all. And even with the simple binoculars, we were able to see a lot of deep sky objects, and it was really mesmerizing. What I learned from that experience was that when we talk about astronomy, most of the times the first thing that pop up in our mind is a very expensive telescope. But when we go to dark sky, a simple instrument like a binocular can help us to see a lot of things in a wide field of view. And regarding the second question, I would say that if there is any dark sky in any of the regions around us, we should have some policy which could, restricts the usage of light during the evening or night time, and there should be limited people going on inside that area, like some control over people that can restrict the number of instruments which carry light, like cars or buses or something like that. They should be stopped outside that state, or some place where everybody has to walk to the that dark sky with safety protocols, and then they can able to observe such dark sky. That would be a great thing to do. So thank you very much for listening. Yeah, thank you.
Thank you, Masoom. I see a lot of people have questions now. Uh, uh, can we start with the interaction part, ma'am, Mila Mitra ma'am, and Wanjiku ma'am? If we are to do that, we can pick out the questions from chat and people who've raised hands.
Yeah, sure. No, thank you so much for answering those two prompts. I've also seen some of them in the chat. Thank you so much for those responses. Yeah, in closing for my talk, thank you so much for sharing those powerful visions. As a last closing note before we go into questions, I just want to leave you with this. The same night sky that inspired our ancient astronomers to help constellations now guide satellites, delivering internet to remote villages. So protecting the dark skies is about ensuring progress serves all of us on Earth and on orbit. You don't necessarily need to, build a spaceport to be a sky guardian. You really only need to look up, like I mentioned, document what you see, and demand that others see it as well. So that act can be, overall, can be really simple, radical, and citizen-powered and driven. Is really how we bring back the dark skies. So yeah, thank you so much for this opportunity to be here with you today and being able to talk to you guys. I'm really happy to answer any questions, or if anyone wants to continue to answer one of those two prompts, please feel free to do so.
Nice.
So yeah, I think both of us can go through the list of questions and pick some that that we can answer. Okay, so I think one of the good questions is that Dr. Nitin asks, if the sky is full of stars and galaxies, then why is it dark? Actually, lights are much more in space. So that's a very good question, because the way we look at this, when we look at the night sky at a dark location especially, then there's so many stars and so many galaxies and deep sky objects. Then why is it overall dark? It's because of several reasons. One is that there is distance between the stars. There's still, and the distance is a vacuum. So there is space is full of vacuum. So in between the galaxies and the celestial objects, there's vacuum. So it's not going to reflect back. So there's no dust or water particles that reflects back. Also, some of the objects have moved further away, and their light, as seen by us, has now moved from visible to infrared or something. So it's only the very strong telescopes that can see in the infrared. So mostly it is vacuum, and it's still not full of stars, even though it looks like it. And even the space between them is not something we can see necessarily in the visible. I hope that answers your question. So let's see if there's anyone. Yeah, there are some more that people have shared their memories.
We'll pick out the chat questions later. We can people are raising a lot of hands, and we can pick them
Okay.
out. So yeah,
Okay.
Dr. Arnold, ma'am, you can go ahead. Please ask a question.
Yes. So, hello, Mila ma'am.
Hello.
Meeting you after 1 month or so. So, how are you?
Yeah, great to see you. Yeah.
Yes, ma'am. Nice listening to your lecture. And the hands-on that you gave, you immediately showed one app and very useful for us. My memory of dark skies is when I used to take students to visit the Vainu Bapu Observatory. We've been doing it for the past 10 years or so, where the sky is so dark that you see the entire sky like a jewel. But the place where I live is a city where you hardly see 4 to 5 stars even after 10 o'clock, 11 o'clock. So that's the difference between, like Bortle Scale, if I were to put this, it's a huge difference. So preserving the dark sky is very, very important if our generation, the next generation needs to know. Because a village, the sky around a village or a hill, a very rural area is so beautiful, which is not there in the city. And we cannot take the students every time or the children every time to the rural background and show it to them. They should have it in the city also. So my thought and my ideas, probably we can have a designated time period every day when we have lights off. Not once a year, like one day you switch off all the lights
Right.
a day, but it could be every day, or probably we could start with 1 day a month or 1 day a week, where just a designated time, maybe not around 6 o'clock, 7 o'clock, but between 10 and 12 or something, a short designated time. If that can be put across to the policymakers, I think that would do a world of good, because then we would be able to see the stars and really know the wonders of looking up at the night sky, which is totally lost in the cities.
Yeah, so we should bring more awareness, as you're saying. And, there is a dark sky week in April when this focus is made to make people aware through the whole week. And also there's an Earth Hour this month itself, where people just put up the lights for an hour. And maybe that's a good way to go. At least there's an impact made that, how it is dark. But yes, we need to write to our policymakers and have better light fixtures and, put the lights off when it's not needed.
Yes, ma'am. Thank you.
Thank you for sharing your views.
Thank you, ma'am.
You're muted. Yes, you're muted. Please unmute yourself first.
Oh, I'm sorry. Thank you, ma'am, for presenting your views. We have a next question from Annie. Please go ahead, Annie, ask a question. And before that, could you please open your camera as well so that we can see who you address and all that?
Hi, good evening. Thank you both for such an informative talk. I have 2 questions. So basically, for the first session, the question that I have was, shouldn't we also be doing similar protection efforts for radio astronomy and not just optical astronomy, since both are equally important?
That's correct. I mean, light pollution per se, which is what I talked about today, affects more optical astronomy. But as I mentioned, and I didn't lead into that, but this constellations of satellites does affect radio astronomy. So that's a whole different ball game, and of course we should be protecting that too. But I discussed it today from the light pollution point of view.
Right. And also, with the rapid increase in satellites, apart from the space debris, what do you think is the biggest long-term challenge for observational astronomy as well?
Do you want to take that, Kanjumba?
No, you feel free, doctor.
Okay. So
Yeah.
Okay, so you brought up the very good point, because that's going to be one of the biggest problems that's coming up, right? Space debris. So as we all have our needs of needing more and more satellites for all the way from communication, navigation, uh, enjoying our live streaming, and also, of course, for very important reasons like Earth observation and navigation. So we have all the satellites. Where are they going to go? It's like a traffic jam in space. So this is going to be the next big thing of how to solve this problem of space debris, how to bring these satellites, take them away from the low Earth orbit or bring them back to Earth atmosphere where they can get burnt up. So satellite debris, solving this is going to be, and tracking it is going to be a very big space sustainability problem. It already is, and it's going to get worse and worse unless we find the solutions for it. And there are solutions that are being planned by the space industry, like lasering them or harpooning them and dragging them back to the atmosphere, or nudging them to a higher orbit where there may not be so much of a traffic jam. So these are all things that will happen in the next few years.
And just to slightly add, I'll slightly add to that is, unfortunately, fortunately, there are a lot of solutions actually mentioned that have been out there for the last like 30 years about this whole thing. But the main thing is that policy-wise, a lot of politicians from different countries don't really see the urgency for something like this. So it's quite unfortunate that I remember hearing this from somebody who stated that the only time really we're ever going to deal with any debris issues or having a very active space management sort of authority that really mitigates a lot of the upcoming issues, or the current issues and the upcoming issues that we'll have, is when something catastrophic happens, where maybe some space debris comes down on Earth and maybe wipes out a city, and there's just a lot of casualties. That seems to be the only time politicians will ever try to take this completely seriously, after years and decades of people trying to tell them, hey, we have all these solutions, but policy-wise, no one really cares. So it's an unfortunate type of thing that we have solutions, it's just implementing them. There's nothing out there yet. It would be great, but yeah, it's a dark way of looking at it. But unfortunately, I feel like that's really is the reality of the situation.
Right.
Thank you so much for both of you taking time to give us this talk.
Thank you for your question.
Thank you, Annie. We'll now take Advik's question. Astrogod, please go ahead and ask your question.
Yeah, so I have like 3 questions, okay, like for Dr. Mila Mitra. So what I want to ask is that, like, first, like I want to build a career in astrophysics, on astrophysics, sorry. And one thing is for sure, like I have actually written a research paper on it. So like I don't know like how to like start, like I don't know how to start in this field.
Advik, before you go ahead, please open your camera as well so people can understand how small you are and how things
Yeah,
work.
that's right.
I'm in 7th grade, by the way.
Yeah. Please open your camera so people can see.
Can you guys see me? Like,
No, like, you're not visible to this.
yeah. Now you can see.
Yeah.
So yeah, great. I mean, it's great that you're interested in astronomy, and we have, of course, the best people here who can guide you, because besides what the two of us will share, we also, Propagation Institute, and please join the SA Citizen Science Group. Mr. Shovin Acharya is here today, and many people in that group give this kind of guidance to students like you. But yeah, in short, if you have a research paper, yes, please bring it up in that group. Again, Propagation Institute can guide you on how to join the group, but maybe okay, he's on the
I'm already there.
Oh yeah, so yes, you can somehow take this paper forward, but the problem in India, as Kanjumba also shared, that at the bachelor's level, there are very few places that you can do astronomy or astrophysics. So in a sense, you will have to wait till your master's level, till you find astronomy, astrophysics places. So till then, you'll have to build up your basic science, physics, math, computing, and keep doing astronomy projects. So you're building up your CV and showing that you have participated in workshops or projects. And this is true for everyone who are in school, who are interested. All you can do right now is keep your physics strong and your computing strong and keep participating in astronomy projects. And finally, at the undergraduate level, there are places where you can do physics undergraduate with space physics focus, including IIST, which is ISRO's own institute in Thiruvananthapuram. And there are some ICERs, and eventually you can do a master's or a PhD. So that is the way forward.
Okay, and like for like the only question was about the bachelor's level, as like they're like, as you already mentioned, there are like very few
Very
institutes.
few, and they are not purely astrophysics or
Yeah,
space physics.
yeah,
Except IIST, there would be a mix, and that is again the best way to go, because that also gives you a parallel track in case you change your mind and want to go, say, into space physics or rocket science or atmospheric physics. These all, nowadays space is very interdisciplinary, and all of these feed in.
yeah.
So you can go to any of those also if you have that experience at that point. Climate sciences, engineering, rocket engineering. So there will be many more options available to you. Right now you see astronomy because it's so exciting, but there are other things that will be also very valuable
Yeah.
professions that are connected to space.
Yes. And yeah. That was all I had to ask. That's all. Thank you.
Thanks for that question.
Yeah.
Thank you, Advik. We can go now to Supriya. Please go ahead and ask a question.
Good evening, ma'am. I'm Supriya from Tamil Nadu. As I have the opportunity to interact with you guys, and I'm more specific with the Voyager mission. And where are the Voyager spacecraft currently located, and what scientific observations are they making in interstellar space?
Yeah, so very good question. It may not relate to today's topic, but it's a very good question. So Voyager, the two spacecrafts, they observed the outer planets, and now they've crossed the heliopause, which is considered the extent of our solar system. So as they both had interesting trajectories that took them around the outer planets, and they gave a lot of information through their signaling at that point. And now they've also still signaled that they are at the outer edge of the solar system. So I don't know what will happen beyond that, but it's just already the fact that they have sent signals back helps us build deep space communication and has helped us understand about the outer planets.
Thank you so much, ma'am.
Thank you.
Thank you, Supriya. We can take Anishka now. Please go ahead and ask a question. Before that, you could also open your camera and so that we can interact with you better, please.
Good evening to both the ma'ams and the Propagation Institute. I am Anishka and I'm currently in 8th grade. And before one of the students, there was a boy from 7th grade, I guess. And he is from now writing research papers. And here I am, not even aware about what to do next. I am even scared about my boards. And as ma'am said that it is kind of tough to join this field, it makes me scared and I'm not sure. I'm kind of very much like not confident about my academics. So I am seeking for some guidance.
So here's a talk I give to younger kids saying, firstly, Anushka, please don't be scared, because just be comfortable and enjoy. Right now, you're at an age where you're not doing your PhD, so you don't have to worry about the outcome. Okay, so you can enjoy it. Nowadays, there are people, I ask people, are you interested in biology? Some people say yes. Are you interested in gardening? Some people say yes. Are you interested in being, in art and design? So nowadays, there are many interdisciplinary fields which will feed in. So you can even be a user interface designer. and still maybe have, if you're interested in space, you build up that background and you might have an option. When Shubhanshu Shukla went recently, one of the experiments was how the user interface works for an astronaut. There are also space doctors. There are space lawyers, like she mentioned that space policy is becoming a big thing. So you don't have to worry about exactly how your pathway will map out, and is it very technical, is it difficult, because just keep your interest in space going and do well in the boards. Okay, so you have a lot of years left to make that kind of decision. Okay, so right now just do well, because it is a tough field, like she said, and you know but now there are many other ways to approach being part of space. I myself know somebody who's a space artist, and she's become very famous. She paints pictures of the moon or deep sky, and she tries to teach students through that. So there are many other ways that don't worry about the technical level right now. Do well in your boards, only focus on that, and do astronomy for fun, like the kind of project I told you today. So just enjoy it right now, and later on you can figure out how to build your interest and your experience more. But the kid who talked a little while back is quite an exception, so you don't worry about that. Just stay steady on your path right now.
Yeah, I was going to also give you some advice. Fantastic advice from the doctor. I 100% agree on that. One aspect that I was able to figure this out a bit later, but given that I can give this to you as early as possible. Don't despite the fact that you started off saying that you're comparing yourself to somebody else. Don't, when it comes to comparing yourself to others, I try to think about it is looking at others as inspiration, but not as a measuring stick against yourself. So what I would say for you in giving that sort of advice is that when you're trying to compete with something, don't try to compete with other people, but compete with yourself. Try to prove yourself to yourself that you can do it. Don't try to think about what other people are doing or accomplishing. You focus on yourself and try to compete with yourself and prove to yourself, hey, I can do this. I can accomplish this. I can do great with my grades. I can accomplish great things. Like, you focus on you to try to do what you feel is successful for you, not for other people. It's your success. So yeah.
Thanks a lot, ma'am. And at last, I would like to say sorry because I created a mess in the chats. Actually, I was having some issues with my keyboard and I just messed up with two of the messages. And thank you very much for your guidance. And I'll take your words with me and will do great.
Yeah, all the best.
Thank you so much.
Thank you, Anushka. It's absolutely wonderful. Now we can take the guru. The guru. Okay.
Abhay sir. Abhay sir.
Abhay Srivastava, sir. I'm sorry. The name tag was a bit. Okay. Go ahead. Please ask your question. Open your camera and your mic. Abhay sir, are you there?
Yeah. Okay.
Okay.
Abhay sir, are you there?
Oh,
Yeah.
yeah. Very good evening to one and all.
You're not audible properly, sir. Please come closer to the mic. Okay.
Yeah. Now you are getting my voice.
Yes,
Yeah.
sir. Yeah.
Okay. Thank you. Thank you for your informative session on this space exploration. Actually, I have registered for the space exploration as I am also doing the MSc in physics right now. Uh, but for teaching or educating my students, a lot of women and lot of girls are there in my contact, those who want to means create some career in this field, and some boys also are there. So I just got the invitation from your side. So I have two queries, ma'am. One is that one of the message in your chat that Propagation Institute is going to organize one of the career program, I think summer school.
Yeah.
So what could be the procedure to get in that? So may I share with my students in those who are in class 9 or 8?
Uh,
12th,
okay,
they are going to be do that.
okay, sir. If you are okay with it, so we can just talk on call. Okay, I'll just text you right now my contact number. Okay, from there you
Okay.
can just call me directly after half an hour. Then we can just talk about it. Okay.
Okay, and the second query, is there any role in which I can be fit for this program in multiple schools, or can I share your details to other one? So
Okay, sir. Both things will talk on call if you're okay with it. Okay, sir.
okay, okay. Thank you so much, ma'am.
Thank
Thank you,
you.
sir.
Thank you, Akshay. We'll take Harshita's question now. Harshita, you may go ahead and ask your question.
Good evening,
Good evening.
ma'am. Good evening, Dr. Mila ma'am and Wanjiku ma'am. And thank you so much for, first of all, this informative session. My question was, as we all know, like how much AI is, helping in different fields, and there are many people talking about how AI will subsequently replace many things in this field, like especially in astrophysics world. My question was like how we can use it in this, this problem, the problem of light pollution. How can AI help us to control, the unwanted lighting and all? It's like I was thinking about it so much lately. It would be nice to hear your perception over it.
So, so I haven't really thought about how AI could help dark skies, but as it's in astronomy and space exploration. I see AI being used in a very nice way. Unlike some places where AI can, you feel AI is going to take over the world, but in space sciences, for example, uh, because you want robots or rovers or satellites to go where there can be a lot of dangers, a lot of radiation and terrain that is unexplored. So AI can be really good at being the experience that figures out all that. And the other thing is that there's so much big data coming in now. There's so much, so again, AI would be very useful in analyzing, getting to these answers, because it's getting beyond the point where humans can look at it. So if well governed by humans, AI can really help in astronomy platforms. Yeah, and finding astronomy in patterns in a lot of large data. And also, like I said, in rovers, or even in Chandrayaan, we had an AI as it was landing that was helping give the intelligence to how the landing will happen. So for dark skies, I don't know yet, because it's very human. It's a very human problem, really. But maybe it can help in like governing the number of lights that are on, or keeping a watch on that. If things are more automated, it could help that way. So yeah,
Thank you so
that was
much,
my
ma'am,
answer. I
for
don't know
your
if,
perception.
yeah,
Um,
thank you. Thank you for asking that.
I would like to thank you so much, ma'am. I would also like to hear from Wanjiku ma'am, like what she thinks about this problem.
So similar to the doctor, I have not looked into AI in terms of astronomy, but what she said is, I think, yeah, might be the way forward when it comes to AI. There was one point that you brought up of replacing people. I know that's the typical fear that everyone has, and I think it's always going to be like that anytime we progress as a species with new technologies and everything. there's always that panic with people of, oh, my job will become obsolete within the next 10 years or 20 years. But the one aspect that if you look through history, but also one aspect that you can look at as a species is we are very adaptable. We adapt to different situations. That's what has helped us really to continue as a species around the world. So yes, there might be some occupations that become obsolete, but it will give opportunities for new occupations to come up that need to be sustained with these advancements in AI. So wouldn't look at it as more of a scary thing that is going to prevent you from progressing, just trying to find different avenues and different perspective into looking about these advancements in AI and how that can be implemented within the space sector is what I would say. Yeah.
Thank you so much, Mila ma'am, for your knowledgeful insight. Thank you so much for your time.
Thank you.
Thank you, Archita. We will now take Shubham's question. Shubham, you may go ahead and open your mic and camera and ask a question.
Hello.
Yeah, Shubham. Yeah, go ahead.
Hello. Hello. Am I audible?
Yeah.
Yes. So, thank you everyone for this wonderful opportunity. Thank you both of the speakers for this wonderful session. I am right now employed as a senior research fellow. I'm doing basically PhD in the domain of heliophysics. Right now, my focus is on ionospheric response to geomagnetic storms. So right now there is a common belief in the ionospheric community that data analysis, though, is always beneficial for studies, but simulations will aid further studies. So one of the aspects of my PhD is magnetohydrodynamic simulation. My question is that considering that as the pivot, if I, after my PhD, try to change from pure heliophysics to astronomy, my career, while keeping the magnetohydrodynamic simulation aspect same, are there opportunities for me in that direction?
See, I'm not sure we know the answer to that question, but if you keep that pivot, or if you even keep, like by now that most jobs, like the next thing, which will be a postdoc for you, they usually hire based on your specialization. But people do change, so if you do keep that as a pivot, you can and whatever modeling and simulations you're doing, if you keep those technical sides also as your strong point, you might be able to grow around that. But I think you're in a good field actually compared. It might even be a better field than some parts of astronomy, because right now the sun is very much being studied, and this field is going to go on for a while. Right now it was in a strong solar cycle also, and there are missions also going, Aditya, SDO, Parker. So I feel it might be a good thing, but yeah, it's going to be tricky, but possible if you keep those focuses and highlight them. But by this time, when you're at your PhD level, you're specialized enough that it is a little difficult to change.
Yes. Thank you.
Thank you, Shubham. We'll now take Dhanvan's question. Dhanvan, you may go ahead.
Hello, everyone. Hello, ma'am. Both of you.
Hello.
It was a really nice, very engaging, informative session. Quite recently, in September last year, I think, NASA had found some kind of evidence, I think I should say, of life on Mars. Quite strong evidence. So my doubt was, if Mars did indeed once support life, is there a chance it might do so in the future again without humans interfering with anything?
So yeah, again, a good question. It is again very tricky. So they hadn't so far, NASA or ESA, nobody has exactly found life, but they found evidence for life, as you're saying, and usually that evidence means organic molecules or the possibility of organic molecules. So then, and that is what astrobiologists are looking for when they search for life, because they want to see, is there organic molecules, and if there is, then is there a sign that there was habitable conditions in the past, or is it still habitable conditions? So that's why, like Mars, for example, the canals and the volcanoes are such that it suggests that there could have been life, but is it still true? Because are the conditions still feasible for life? And that may not be so. So what we're looking for is, was there life in the past? Is there sign of organic molecules now? And is there habitable connections now? So all of these have to be true to say that will there be life again. But that is what we are looking for, or sign of such molecules, and what could have created in terms of the chemistry, in terms of the geology, what could have created them. So far, there are only possibilities that there are signs of life, but they haven't been exactly found yet. So would you like to add to that, Wanjiku?
No, thank you.
Oh, okay. For me, in terms of adding to that, yeah, I agree with her assessment. It's a very fascinating question, because, to be honest, I've never found myself asking that later on in the future, because what I was imagining once you ask that question is, well, the sun is going to expand at some point. It's going to become a red giant. So the habitable zone that we have will shift back and might end up being Mars being more habitable than Earth at some point. But will it be in a habitable zone where it has enough time to have the conditions to have, sentient life that develops within the planet that has no interference from humans? That's an interesting question to consider. But yeah, you put me down a rabbit hole. I think I'll be thinking about this for the rest of the weekend. So thank you.
But there is a lot of astrobiology, astrochemistry. These are like big missions. There's a Europa Clipper mission that's going to Europa because it has icy methane ejections. So there's Juno mission. So what you're saying is, and of course there are exoplanets that are being looked at for habitability. So do follow along with this news, because it's going to be there's going to be a lot of exciting findings in the next few years. Yeah, and thanks for bringing up astrobiology. This is a very key question right now.
Thank you, ma'am. Thank you very much.
Thank you, Dhanvin. We'll move on to our next questions. Padmakshi, you can go ahead and ask your question.
Okay, thank you. Good evening, sir and ma'am. Myself, Padmakshi Sarsat, and this is Roshni Sharma. Actually, we are working on a student small focused initiatives that is related to space, and we are deeply interested in quantum physics as well.
Actually, we both are partners.
Okay.
Okay, so we are working on a student-led space startup, which is known as Aerospace Labs, and we launched it in the past December. So we have a question that, do you see any realistic intersection between quantum technologies and astrophysics research, where early stage student startup like us can meaningfully contribute?
So I'm not, again, sure of that answer because it's very specialized. So if you're doing that, you might have researched. The only way that I know that quantum technologies are being used right now is in, is in space data, for example, because, the protection of space data is very important. So quantum technology is being used for that. So is yours also to do with data?
Ours is all do with rocket data and a little bit about space debris.
Okay. So yeah, I'm not really sure how it relates to space debris, but yeah, I know that it's being already used in by ISRO also in space data encryption.
Okay.
Yeah.
Thank you, ma'am.
Okay,
Thank you.
ma'am, I would just suggest these two people one more thing. There is one more professor, basically PhD scholar, who is just working on space debris. Okay, if you want, we can just connect with them. Him basically, he is the professor, and he's having a professor from Oxford University, and both are working on the space debris only. So if you have any doubt, you can just connect with them as well. So what you have
Yeah,
to do is
sure.
just text me on propagation.connect, okay, and I'll just send you their connections.
Okay, that would be very great.
Yeah, thanks. I think they need that more specialized connection so that, yeah, that'll be
Yeah,
right.
he's having.
Right.
Thank you so much.
Thank you.
Thanks.
Thank you. There are very great amount of people with startups today as well.
Right.
Nice.
Everyone is doing that.
Yeah. Okay. Nikita, you can go ahead, please. Nikita and Roshni.
Good morning, ma'am and sir. I'm Nikita Charan. Am I audible?
Yeah.
Ma'am, I have a doubt regarding how all the small and big things are created in universe. We believe that our universe is created from nothing. Then how electrons, protons, atoms, different elements leading to the creation of stars, planets, living organisms are created.
So what you said is the whole timeline of how the universe was formed, but that's how it was formed. I mean, again, like what we piece together from studying the universe is only from information that we have derived through studies or observations. So the theory is that when the Big Bang happened, then for a time there was no electrons, protons. It took some time for these electrons, protons to start, and then they combined and formed atoms, and then slowly, they formed hydrogen and helium, and then that's when it led to formations of solar systems and the suns themselves. Different suns process the hydrogen, helium at different times and make heavier elements. So there's the whole thing. It started from that nothingness to a recombination that created these elementary particles, and then the elementary particles created, and then they formed their own solar systems, and the solar systems process them further. And that is why we see suns at different stages of life cycle that have, depending on their mass and their formation, they're rich in different kind of elements. So it started in a very complex way, but then it went along different pathways depending on how big the star that got created turned out to be. So this is, it's a continuous process of nucleosynthesis where elements are fused and new elements are created. So that in short is how the universe was formed.
Thank you, ma'am. Ma'am, I have a doubt. Ma'am,
Yeah.
currently I am pursuing MSc Physics and I am interested to have a career in physics and astronomy. Then what skills and steps I have to take in future?
So what did you say your background is right now?
Currently, I am doing MSc Physics.
Okay. Yeah, so from chemistry, I mean, you can also look at this astrochemistry, because that's also a big thing right now of, how, again, the origin of life from the chemistry point of view and the habitability from the chemistry point of view is also going to be a big topic. So, or you can think of planetary geology. So there is chemistry that fits in, and you can probably think of that pathway. But otherwise, the skills are there's a different kind of skills, because if you go into pure astronomy, it's different. And you can go into some engineering aspects that are different. But yeah, pure astronomy, you'll have to do a master's or a PhD in the fundamental astronomy and the advanced astronomy kind of courses. But yeah, I think you should look into astrochemistry even as a specialization.
Thank you, ma'am.
Thank you.
Thank you, Nikita. We'll take a few last questions, maybe one or two more, since we have a time cap as well. People are busy. Dhanwin, you have another question? Is it?
Yes, I do.
Okay, you can go ahead.
What were the precise circumstances which led to the theory in the mid to late 19th century that there was a planet between Sun and Mercury, and they called it Vulcan?
I am not aware of that. I don't know if anybody else here can.
I actually know this answer.
Yeah, Dick. Okay, go ahead. Explain.
Yeah, so basically, like, do you know about that scenario when there was a planet disturbing the orbit of Uranus?
Of Mercury, I think.
This Vulcan is for Mercury and Neptune was for Uranus. So basically, it's here only. They just thought that Vulcan was a planet. So you want the time period of it, right?
So we may not be able to conclude this discussion, but usually what happens is if by observation scientists feel that the planetary body, any planet, the orbit is changed or disrupted or is in a wobble. So these are usually thought that it's under an external influence of some other body that's tugging it gravitationally, right? So that's what could have happened, because even right now there's a thing going on that there's a second moon. That which is it's actually a small object that is keeping at the same distance as the moon and going along with Earth. So these are external objects that can hamper the gravitational force, and that is when you think that there is another planet.
And there are still theories circulating about Planet 9.
Right. And yeah, one of the big citizen science, there is a big citizen science project also on Planet 9. Yeah. Yeah. So again, it depends on how you define, that, all these definitions will have to hold about how far away is it, what is the size of it, does it have a clean field that its orbit is going through. So, these all have to be looked at. Yeah, thanks.
In terms, I was gonna say, in terms of that, you're giving that theory. It ended up making me think about the theory of how our moon came to be. Is that there was something that had a somewhat similar size or just a smaller compared to our Earth. They collided, and the remnants of all of that ended up forming our moon. So there's also that concept that back then stuff like that did happen. It's not really permanent right now within our own solar system, but it does go into some sort of explanation of how our solar system came to be.
Right.
All right. We will take one last question before we conclude today's session. Masoom, you can go ahead. Please open your mic and camera.
Yeah, so sorry for barging in again. And I have a question for both of you. It's very rare that we get an opportunity to interaction with very eminent people like you guys. So my question is to both of you, if you can suggest few good books which our audience can read and they can get inspired in astronomy, that would be something that I would personally feel a takeaway for me, because whenever I will read that book, I will feel that, oh, that session ma'am has suggested some book. So I would request you if you can suggest one book that inspired you to pursue astronomy, that would be a great thing. Thank you in advance. Thank you. Thank you very much.
So, Masuma, I know that we were both at the same conference recently where this came up. And yeah, for me, of course, for a lot of us, the books that inspired us were books like, Cosmos by Carl Sagan, or Feynman's lectures. But one thing I want to point out to you is there's on OpenStax, there is a book of astronomy. And Masum, I'll try to share that book with you. That's a free book, Introduction to Astronomy, and that is used at the undergraduate level in the US. And it is free, and it has very good chapters, and it has very good examples throughout. It's by Frank Noy, I think, but I'll find the book's name and give it to you. It's on OpenStax, so it's freely available.
So for myself, I would, if I'm looking back to when I was younger, I would say the one inspirational astronomy book was definitely Carl Sagan's Pale Blue Dot. Like I mentioned at the beginning of my talk, it's, just seeing all our history in that just one image that the Voyager took really puts a lot into perspective. All the history, all the people that we know from, who have been influential, changed our world, maybe in positive or negative ways. But there's that small pale blue dot we call home. That mesmerized me so much. There's only so much when you look at images from, like, say, the International Space Station, of seeing our planet, or from the images that were taken from the moon, like during the past moon landing. Only puts so much, it puts it there, but I feel the Pale Blue Dot by Carl Sagan really sparked a huge appreciation for astronomy.
And same way the Cosmos series also by Carl Sagan. Yeah. Which are also books. Mostly we think of them as movies, but they're also books. Yeah.
Nice. This was an absolutely treat to watch all the fantastic people interact. We will try to conclude the session here. By the way, a lot of questions are there in the chat, and a bunch of answers to your prompt, ma'am, were there in the chat. But since we have a time cap, we will try to conclude it right now. And for people who are in startups or people who want help on certain questions, you may reach out to us on propagation.connect@gmail.com. We'll try to paste that on the chat and ask us of any help that you want from us. We will try our best to get you that help. And with that, I would like to thank Wanjiku ma'am and Dr. Mila Mitra ma'am. It was an absolutely fantastic session. We loved it. I learned a lot of stuff. People, I think, have learned a lot of stuff. People have got their answers. An absolute treat to watch. Okay, now we will do one last formality. I would like for you to all open your cameras so we can take a quick picture, and so that we can remember today's session. And that will mark the end of today's session. Yep, open up your cameras.
Just wait a second. Everyone, please turn on your camera.
Yeah, turn on your cameras.
I would request Sohan sir as well. Sir, please turn on your camera. Everyone is turning on their camera. Okay, nice.
Give me a second, Bill.
Okay.
Okay, yeah, got it. Thank you. Thank you, everybody.
Before we finish this session, I have to tell you a few people something. Okay, if any one of you are interested in the astronomy and all, so there is a very interesting example we are having. That is a Sohan Acharya. Okay, if anyone do not know about him, let me just tell you about him. He's the guy who is not belonging from the space science event, not belonging from the physics background, but he has done lots of things into it. Even if you'll ask the Mila Mitra ma'am as well, so she will just tell everything about him. So I would request Mila Mitra ma'am, please tell about everyone to everyone about the Swan Acharya sir. And we are having the Swan Acharya sir as well. So I would request Swan Acharya sir, please turn on the camera. And he is the person who just started the AC Citizen Science Group, which is India's biggest citizen science group, by the way. And yeah.
Yes. So again, thank God he shared his picture. But yes, so I've known him for a few years, and he has quietly spread this whole movement of citizen science, and it started with a few people, and now there are all the way from school students to professors to young amateur astronomers to photographers, and everybody gets a voice. And Shovin sir himself has a background in engineering, but he's so passionate about astronomy, and he keeps sharing about different projects. And when he shares about different projects, then people add their viewpoints. So it's dynamically growing all the time. And he doesn't take the credit. He's very quiet about it, but he's really spread the movement. And he's got a lot of a huge network now underneath this umbrella. So there's a lot to be learned and a lot you can participate. So do join along with this group. And really, Shovin sir, you're a great example of somebody who's done all this, such a strong effect very quietly, and made this whole group go forward by leaps and bounds.
Sir, I would request you to say a few words.
Thanks, ma'am. Very much interested and participate and encourage also. This is my motivation and work. In easy way, get WhatsApp group and Telegram group, so people can participate in any time, anywhere in the world. This is my short introduction.
By the way, thank you so much, sir. Thank you so much for attending complete session again. And thank you so much, ma'am, Mila ma'am, for your time.
Yeah, thank you. Thank you for inviting me. And thanks, audience, because it was really nice interacting with you. There were so many great questions. So yeah, enjoyed the session.
And I would like to say thank you so much, Wanjiku, as well. Like, you just be ready for the session very quickly whenever it's asked. So,
Yeah. No, I appreciate you reaching out to me when I asked you to. So thank you. And giving me some time to finish up the work I was doing.
Okay, then thank you so much. Thank you so much, everyone. So yeah,
Thank you.
Thank you.
Bye. Bye, everyone.
Bye.
Good night.
Bye.